Really, the goal for today's lesson is to set up problems involving ratios, and we're going to cover also applications involving direct proportion. And that's basically it. So I'm not sure how long the lesson will take, but that's the topics that we'll be looking at today. The first idea that we're going to look at is the actual property of what a ratio is. So a ratio, when dealing with two quantities, is no different than a fraction. So you see, for example, on this page here, on the first example there, you see we have 18:48. That's a ratio. You could also write it in fractional form and also reduce the ratio as well. There's various ways that you can express the ratio. But when you have single ratios, really what you're ending up with is a fraction of some sort. So what I'd like to do is start off examples, just like you see here in the earlier examples, if you've looked ahead in the notes, where we're reducing single ratios. And I've chosen 3 or 4 questions in the exercises, which you can find on pages 5 and 6. And let's just see what we have here. So we're going to be doing questions 1, I think it's 4, and also one on the next page here, which is number 8. If we find that these questions go by quickly, I'll do some more questions with you. And that's basically just kind of opening you up to review of ratios. In the Ontario curriculum, ratios are studied very early on. So some of you might not have done math for a long time. And that's really the target audience specifically here, is people that haven't seen this for a long time. But I don't think that you're going to have too much stress when dealing with these questions. That doesn't mean that I'm just going to go really fast through them, though. So in this first example, we have simplify the ratios and write them to lowest whole number form. So we'll start with question A, and let's see how this goes. So question A says that we have 8 inches to 24 inches. What is the answer to this question? Anybody know what do you think the answer would be to this question? Final answer, what would it be? So it hasn't been done for a while, I'm guessing. 2 to 12, 4 to 12. That's a better version of it. Yeah, you would reduce it. So what Nicolaus is doing there is trying to reduce the numbers. Yes, Nicholas, that's even better. 1 to 3. Now that symbol in between should be a colon, right? There you go. Okay, good. I was assuming that was a keyboard thing. So the answer is 1 to 3. But let's see how you get there. Whenever you have a ratio, whether there's 2 quantities here, we have 2 quantities here. We could have a ratio with more than 2 quantities. What you can do always is you can divide both sides of the ratio by the same thing, just like with an equal sign. Excuse me. So what I'll do in this case is I'll divide by 8. I'm not done with this yet. I'm just going to say 8 temporarily, but you'll see where I'm going with this. You can divide by 8 with both, but that doesn't deal with the inches. When you have ratios you can always be reduced in a way, hopefully, that the units are simplified. In this case, since the units are both measurements of length on both sides, it would make sense that the units should eventually cancel out. So that's what we're trying to do here. We're going to try to cancel out the units, and the easiest way to do that is to divide both sides by 8 inches, because then the inches will cancel out as well. So that's the strategy. By dividing both sides of a ratio by the same quantity, you can reduce it, no different than when you deal with a fraction, which is why ratios and fractions are so similar in terms of strategy when you deal with them. Okay, now question B. There's a little bit of a hiccup here. What's the issue with this question? Anybody want to tell the class? What's the issue with this question? We have a little bit of a situation, don't we? Units, yeah. Thank you, Sheldon. So on the one side we have feet, and on the other side we have inches. Thank you, Norris. So we could either turn the feet into inches or the inches into feet. It's probably, I mean, this is a nice one because 6 inches is a very nice value in terms of feet. It's 0.5. But I'd rather make things whole numbers if possible because whole numbers reminds me of the good old days when I first learned fractions. So the first thing I'm going to do here, not that these aren't good days either, but anyway, yeah, let's turn that into inches. So we're going to do 3 times 12 is 36 inches. Now we can play. So now what we're going to do is take this ratio and divide both sides by the same quantity. It would make sense to divide by 6 because 36 is also divisible by 6, and it's the greatest common divisor. So there you go. We can divide them both by 6 inches. What's the final answer to question B? That's right. You know, these questions, if you let's say that you are not understanding how to do this and you have no idea how to do it and you're really confused or whatever. I'm not saying you are, but let's say that you're trying to explain to somebody that's very bad with measurements. What you could literally do is get a measuring tape, measure out a piece of material, like maybe it's a wire or something, measure it out. Measure out a 3 foot wire and then a 6 inch wire and lay them side by side. And then you can kind of show a person visually that you can fit 6 of those 6 inch wires to make a 3 foot wire. Kind of, you're just comparing two quantities. So that's A and B. I'm going to just do C, D, E, F, just trying to fit it all nicely here. So here comes the next pair of questions. I don't know what that blue thing is there. That's weird. Okay, we're on to question C now. We have this time something involving currency. We have 25 cents. Is that the symbol for cents in this shortcut? No. I'll just put C for cents. Actually, I'll just type it in full. 25 cents. I'm having more difficulty typing a number in than I have doing the question. That's hilarious. Okay, 25 cents to $1. You can convert both of these into dollars or into cents. You can also ask a simpler question. How many quarters fit into a dollar? Well, a dollar is made of 4 quarters. So you can play it that way as well and avoid uh, divisions based on experience. I'm going to turn these both into cents. So that's 25 cents and then 100 cents. So what does that reduce to? What does that reduce to? That's why. That's right, Nicolas. It's 1 to 4. So I'll do the extra step here for people that want to see that, and that's totally cool. We'll divide by 25 cents. And there we'll just divide by 25 cents as well. You see the left side reduces to just 1, and the right side is 4. Where do you see ratios in everyday life? Well, whenever you're doing anything from cooking to looking at a map to portioning out materials for a project, all of these things involve ratios. Even when you're calculating, for example, pay rate. You know, you work so many hours, you get so much money. And let's say you get so many dollars per week, then how many dollars per month, dollars per year, etc. Um, very, very, very useful and very practical everyday life stuff here. In the next situation, we have RPM. What does RPM stand for? What does RPM stand for? Rotations per minute. Thank you. So we saw one. I think we saw rotations per minute on an assignment or something. So if you ever, if you ever drive a car or whatever, if you drive, you'll often look. You have two gauges on your car. One tells you your speed, and then another gauge usually that most cars have is an RPM gauge. So you'll see something like this. You'll see a wheel on your car, and it'll say like 3, and then it'll say in thousands, something like that. You ever seen that on your car, the gauge? What that's saying is, if let's say that you're going at a particular rate, and the engine's working in a way that it's rotating or completing a cycle 3,000 times every minute. That's what that's saying, is that your engine is doing 3,000 revolutions per minute in terms of how it repeats its pattern. Okay, so in this case, we need to reduce this. So we can divide both sides by what? What would you divide both sides by here? Very nice, Nicolos. Yes. The greatest common divisor is 50. That's 50 RPM on both sides. That's 50. That's 5, sorry. 5 to what? Thank you. Okay, the next question involves some decimal calculations, but still, these are decimal quantities that we could, of course, write them better in terms of whole number quantities. So we have 0.8 meters and 20 centimeters. I thought about what's the largest number that divides into both 250 and 350. There's other ways of doing that as well. Let me show you something that you can do that's better maybe in your head as well. This is not directly specifically at your question, but maybe it supports other people as well. I just have to zoom out for it. Sorry. What you could do here as well is you could just knock off a 0 for each of those because you're dividing by 10 essentially. And that's good for mental math. And then you can do 25 divided by 5, which is something that is a little bit easier to process. That step there is not necessary. It's just whenever you have zeros in a ratio, you can just chop them out just by slashing them and reducing them. We'll approach that strategy here as well. We'll approach this question with that strategy as well. Firstly, let's make these both centimeters. So this is 80 centimeters. Yeah, exactly. Just find the lowest divisor, the greatest divisor you could find. You don't have to pick 50 right off the bat. You could pick any number that divides into both and reduce it. Yeah, whenever I'm doing the ratio questions in my head, you're welcome. Whenever I do ratio questions in my head, I don't like try to hit a home run. I don't necessarily try to find the biggest possible number. I will just do baby steps. I'll just do baby steps and kind of recite it in my head so that I can get it faster. Like here, okay, here it's 80 to 20. So what I would do is maybe just in my head I'm saying I would do 8 to 2 and then I would do 4 to 1. So like this is what I'm doing in my head here, okay? For this question I'm doing 80 to 20. I get rid of the centimeters right away. And then I would do 8 to 2 and then 4 to 1. That's the process that's going on in my head. But I like to do little baby steps. I don't like to do big steps because you know what? It's not fun to do. I don't want to gamble. I want to take a risk with my mental math. In any case, here I'm not going to take baby steps. I'm going to try to find the largest number, so that it looks like the most efficient answer on paper. So in this case here, they're both in centimeters now. What should I divide both sides by? What would you divide both sides by here? That's right, Sheldon. So this step that I'm doing with the fractions, you don't have to write this step down. I'm just doing it to show you how to approach the question in a structured way when you're writing it down. I know that often when you're doing math, you'll do questions and you'll get the right answer, but maybe you have a little bit of a challenge to write it on paper to communicate that to somebody. So because these questions are relatively easier in the big scheme of things, I'm making a little bit extra effort to show you how to communicate those things to other people. Question F. 20 teeth to 45 teeth. We're talking about gears here. If you're wondering what's up with teeth, no, we're not talking about dental situation here. We're talking about gears. Gears. Okay, we're talking about gears. So gear ratios. So think about how you would reduce this question here. First of all, what you can do, now that we've seen this game before, all these questions where I had the units everywhere, let's approach question F in a way that's both structured, thorough, but also efficient. So if you want to find the best way to answer this question, this is follow what I do with F, and you can go back and do the other ones the same way. First, the units are the same. Since the units are the same, you can just cross them out because essentially you're dividing by teeth. Then try to find the largest divisor into both. So in this case, 20 and 45 have a common divisor of 5. That's the largest number that I can think of. So we'll do 20 over 5, and then 45 over 5. And then you have the answer of 4 to 9. If I were to tell you how to study or how to do these questions, I would follow the strategy for F for all of the questions. That's pretty much it. A little bit of an icebreaker. We're going to go and try a couple more questions from this section. And then after that, let's see what happens in terms of your feedback. So when you're ready, I'm just going to give you 30 seconds. Take down what you need. I will post these again on Blackboard at the end of class. So just another 15 seconds, okay? Okay, here we go. So just take a moment to read that question, and I'll pause as you read it as well. Okay, brass is made up of those metals by weight. What is the ratio of the weight of copper to the weight of zinc? Okay, weight of copper to weight of zinc. Let's talk about A here. We want the ratio of weight of copper to weight of zinc. The reason I've capitalized the word to is because 2 is a key word. Whenever you see the word to or is to at that phrase as well, then you know that we're talking about some type of a ratio. In this case, we don't actually know how much copper we have in terms of an absolute quantity. Like I'm not saying to you that it's 68 grams of copper and 24 grams of zinc. What I'm saying is that this recipe is always in the proportion of 68 to 24 to 8. So when we talk about copper and zinc, we can write down the following ratio: 68% to 24%. That's what you do. 68 to 24. And at this point, you can reduce this. I'll do this two ways, the question. First, I'll reduce it to the exact ratio, and then I'll do what the question says there, express in lowest decimal form. So this is an alternative way of presenting ratios in general, and we'll talk about that in a secondary response here. So the first thing is, it doesn't matter how many grams of the particular material we're looking at. So I don't care if this brass, if there's a kilogram of it, a ton of it, or a gram of it, or 50 pounds of it. I don't care. What I care about is the ratio is 68 to 24. which is the first thing I'll do here. Because the percentages, remember percent just means divide by 100. In other words, I could do, this is what you could do if you wanted to. You can make that 0.68 and 0.24 and then multiply by 100. So I'm skipping this step here. I'm skipping that step because when you're dealing with ratios within, percentages within ratios, you can just cross out the percent because essentially by crossing out the percent, you're multiplying both sides by 100 anyway. So my opinion, final opinion, is just cross out the percents. You can pretend the percents are like units, like centimeters or whatever, just cross them out. Just like I did the previous question here. See, I just crossed out the teeth because they look the same. So the percent symbols here also look the same. So I'll just cross them right out. So don't write down the gray thing if you don't feel like it's going to help you. Now, I said that I want to get an exact answer before I show you the lowest decimal form, and I'll just do that here now. So let's just squeeze this over a little bit. Sorry, guys, I'm just trying to make it look pretty for you. Anyway, so I want to do this. I want to do this without a calculator. So I mean, as much as possible. So if you were saying without a calculator, just do it with baby steps. So they're both divisible by 4, but maybe you don't feel like dividing 68 by 4. So don't divide 68 by 4. Divide 68 by 2. So that'd be 34 to 12. Notice that they're both even. So that's 17 to 6. And that's the exact answer. But the question talks about lowest decimal form. So when you want lowest decimal form, then what you want to do here is divide both sides by the smaller number. So what is the smallest number here? It's 6. So if you divide both sides by 6, you get 17 over 6 is to 1. And then you can turn 17 over 6 into a decimal. Someone have that as a decimal? Should be like 2.2 and 6/7, so 2.83, I think, right? Yeah. Thank you, Nicolas. So the answer that we're looking for in this question is this decimal number here. No, that's good. I'm glad you just left it as a repeating decimal, which is just fine. That's good work. So I'm just gonna squeeze that up here. So there you go. Seems like a lot of writing. Perhaps what I'll do with the second question, like the part B, is I'll show you how I would answer it just to directly target the final answer. Because this is a lot of writing and you don't have to write all this stuff down. This is how I would approach the question part B. So the question is asking us to determine the lowest decimal form ratio of total weight to copper. So total weight the weight of copper. So you'll see how fast I answer this question because this is how much writing you really need to do for the question. You're gonna be shocked about how less writing it is. Okay, I know copper. Copper is 68. But what the heck is total? They don't give us total. What's total here? What number do I put here? What quantity? What number would represent the total? That's right, Norris. I'm trying to make it sound scary, but it's actually not that bad. So if you're ever going to go with lowest decimal form, then you don't need to worry as much as I did with the previous version. You can avail yourself of all of these calculations by just dividing by the smallest number. So the final answer is actually much faster, more fast like this. You can do 100% divided by 68%. So what's 100 divided by 68? That's your final answer in terms of the left side. So if you divide those numbers, I think it's 1.47. I just looked at the answer key. So a little cheating there, if you don't mind. Can someone confirm that's 1.47? Sweet. So you see, when you want to get a question like that, don't worry about how much writing you do. If the guy beside you does way more writing or whatever, it doesn't matter. Just do it in a way that you feel comfortable. And back to this question here, I don't want to scare anybody, but if I was asked to do this in my head, this is exactly the steps that I would do, except the gray step. I wouldn't do the gray step, but I would do all this in my head, really. And you're like, how would you do that in your head? Well, once you reduce it, dividing 17 by 6 is not, dividing by 6 is not the most difficult division. If you've done a lot of long division in your life, you'll know that. Anyway, hopefully you have the strength for one more of these. So let's take a look at another one. Yeah, because the total percentage is 100, yes. It's inferred. You assume that the total is 100 because total's usually 100 and other things, so we expect something similar. Okay, so this is like a scale or a magnification for a diagram. You're welcome. So if you anybody ever bought a model toy or something like a toy car or something else, and it's or maybe it's a statue or something, and it says that they'll say like this, okay? Like I built a Lego set with my niece and my nephew a couple years ago, one of those architectural Lego sets. Those things are awesome anyway. I think it's an opportunity for grown-ups to just play with Lego, and I don't mind that. Anyway, we did the Empire State Building, and then the Lego set said something like it's 1 to 250 or 1 to 2500 or whatever it was, I forget, of the building. It was so what it's saying is every inch of the toy represents 2500 inches of the real life quantity. And I'm sure that with blueprint reading courses and other things like that, you'll deal with scale and be familiar with it. In this case, the question is asking us to represent the scale of this particular drawing as a ratio. So we have 3/8 of an inch. I'll just write inch like that. And then we have 1 foot. So how do we reconcile this situation? Well, I don't think it would be beneficial to go to inches because you're just going to get a whole bunch of fractions. But you know what? In this case, that might be okay. I would just go right to inches because that's the safer bet. So you end up doing about the same amount of work anyway. But anyway, so there, 1 foot is 12 inches. Now, what I showed you earlier in question 1, part F, was that when the units match, when those units match, just cross them right out. Don't waste your time, okay? Like just do that. Okay. Now it's a matter of you being able to reduce those fractions, sorry, the fraction on both sides. Because there's no fraction on the other side, it would be a good idea first to multiply both sides by 8. And I'm going to do that here because we don't want to have a fraction. So we'll have 3, and then 12 times 8 is 96. Now, reduce both sides by dividing by 3. You don't have to write these words here. I'm just trying to give instruction. 96 divided by 3. This is nice because 9 and 6 are both multiples of 3. So 32, 1 to 32. So this diagram says that, so basically, if the diagram was a regular sheet of paper, let's just say that the diagram was fit onto one piece of paper, a regular 8.5 by 11 sheet of paper, that the real life situation would be 32 of those sheets of paper side by side and forming a large rectangle. So that's just something fun to think about. How do you feel about this intro to ratios? What are your thoughts, everybody? What are you feeling about it? You feel it's okay? Is this something that you could look forward to on a test? Your test is next Wednesday. Would you like to see these kinds of questions? Yeah. Okay. The question, Norris. I'm glad to hear that. Oh no, the reason that who asked the question? Norris. The reason I multiplied by 8 was just because I don't like fractions. I'm just trying to get rid of the fraction. You don't have to do that. You could do this question with less writing. You could divide both sides by, well, I'd rather you just multiply both sides by 8 because then it gets confusing to explain it. And if it's confusing to explain it, then most likely it's confusing to also implement. Usually, if I try to explain something that's difficult, sorry, a difficult explanation usually results in a difficult implementation. So yeah, get rid of the fraction first. It's just a safer bet. So that's why I multiply by 8. I know your mic cut out, but that's my answer. That's my answer, and I'm sticking to it. I'm not going back on that. So anyway, we have a few more visitors to the party today. So I'm just gonna go back up to the beginning of the notes. Remember that again. I'll make an announcement on Blackboard uh, for today. This is our last class today. This is our last lesson today. There's no class on Friday, so we're gonna be covering the first 3 sections. We just did the first one, which is kind of like the ABCs of ratios. And we're going to continue on doing some application questions here for the remaining lesson. Your final test will be based on sections 1, 2, and 3, and 4, 5, and 6 won't be on your test. Since the reason is that I'd like to finish up the lessons today so that I give you ample time to study for your exam. I don't think it would be fair for us to have a lesson that's literally 5 days before your final test. I've had that happen to me as a student. Some professors give their exams this week, which is even funnier because not funny, but it's just a little bit uh it's a compromise, right? Like I want to have you get you a good test, and I also don't want to have it be last minute things. So anyway, that's why I just like to have it wrapped up today so that we can have focus on a test, focus on studying for the test for the remaining time. Any questions that I take from this chapter will be fairly easy. So like if you like the stuff that we did so far, then you will really like the stuff that we do next week on the test. Okay, so we're going to move on to setting up and solving what are called proportions. So proportions are how you use ratios to compare quantities. So I'm just going to skip over here to section 2, which is setting up and solving proportions. So we have here a proportion that is written in 2 different ways. We have it written as a ratio, and we have it written as an equation involving fractions. So just take a moment to digest what it says there. Let's just zoom in on that. If you're saying, is there a formula or some sort that you need to know here? This is the communication between the 2 different versions. We have the ratio form and then the fraction form. So really, there's a communication level that you need to understand here. Whenever you see 2 ratios equal to each other, you can also write it as the same fractions on the other side. Notice the locations of the letters. So the variables, it's a over b, so you put the first variable on the numerator and the second one on the denominator. We're going to practice doing this for several questions now, and let's see how that goes anyway. So I'm going to just direct your attention to page 9. There's some questions here that we can try. We'll spend some time now with the remaining part of the first hour today doing questions 1, 2, and 6. And then after that, we will take a break and continue on with more application questions. Okay, so let's take a look at question 1 first. So there's 5 of them here that we're going to play with. We have a little bit of an extra layer here. It says solve for the unknown value x in these proportions. So these types of questions, many of you can do. If the numbers were nicer, you could do these in your head and you don't need to make fractions out of them. For example here, if this 7 was, for example, a 1, let's say the 7 was a 1. then you could say, oh, it's 2 to 1. It's a 2 to 1 ratio, and you can tell that x equals 6 very fast. But these numbers are not favorable. These numbers are a little bit annoying. So let's just see how we do with things. I'm going to solve all of these questions to decimal form. It doesn't specify right here if it says decimals or not, but it does say it in the question. See, give all answers to 3 significant digits unless otherwise specified. So I'm going to go with 3 sig figs for all these questions. Let's take question A here and work with that. We have here x is to 2 as 3 is to 7. We can rewrite this question as a fraction, as x over 2 equals 3 over 7. So that formula, or that comparison that I made earlier, right here, this thing here, if you write them on top of each other, then it's really easy to visualize it. You see how if you just stack them on top of each other, it's much faster to look at. Does anybody remember, or what would be a nice strategy, or I should say, that you could use to solve for x? Yeah, that's right, Marco. Good job. Cross multiply, yeah. So Marco's talking about multiplying the x and the 7. So doing this times this and this times this. So that's the strategy that we'll use as well. I'll do here 7x equals 6, and then divide both sides by 7. So x equals 6 over 7. It does want us to round this to 3 sig figs. I would normally do this on a separate line, but I'm just trying to write this compact. So that's 0.857. One key difference when dealing with ratios, when you first learn them in school, is that you don't do them with, you do them without a calculator because the numbers are always nice. But as you know in real life, the numbers are not always nice. So that's why it's nice to see these examples again. Okay, so here's B. 3 is to x as 4 is to 5. Write those as a fraction. 3 over x is equal to 4 over 5. Let's cross multiply, but this time I know that I wrote down these guys, x times 7, the downward ones, I wrote them on the left. I want to write x always on the left. So in this case, these ones that I multiplied 4x, I'll put those on the left. Because when you cross multiply, you could write the answer 2 different ways. You could write 4x equals 15 or 15 equals 4x. Really, it doesn't matter which way you write it. I just prefer to have the x on the left side. So 15 divided by 4 works out exactly. So 15 divided by 4 is going to be 3.75. There's an extra layer of challenge in the next question because we have ratios involving fractions. So let me just copy this down and then we'll discuss together. Okay, what are your thoughts on this question? How would you deal with this? How would you deal with this question with these fractions? Any suggestions? That's right, Sheldon. Bring it on. Bring on those decimals, my friend. I like your style. Let's get some decimals out of this thing. Okay, so we have x is to 3.1, 3.25, 3 1/4 is 2.5 to 6. So basically, if you know how to do this question, you can also find the answers to D and E now because they have the similar situation. Let's write those as fractions. Yes, I realize there's decimals within the fractions, but this situation is transient. It will go away quickly. We have 6x equals a product of two decimal quantities, which does not concern me because the question said that we may require three significant figures in our answers. All right, I guess I'm going to grab my calculator here. First time to grab the calculator today. So that one I could have done in my head, but honestly, it would be faster to grab my calculator for that one. At least I'm not having my full coffee today. So if we divide both sides by 6, we get 1.35. Okay, we'll just try D and E now and then see how that goes. So maybe we won't do both of them. I'll do E with you because D looks like it's just decimals, and I'll be like just punching numbers on a calculator. I think E is a good one because it has those mixed fractions. I mean, it's not often that you see proper fractions. I remember my nephew asking me, when where do you see proper fractions in real life? And I'm like, well, the only examples that I can think of were in the trades, and then I was like, and construction, of course, as a broader discipline. So I'm like, you'll see it in Home Depot, or unless you do anything in the trades. But anyway, still good to know. I don't know the last time I ever saw 2/3 at Home Depot. Anybody ever see 2/3 on something at Home Depot? Or is it just me? I don't think I ever have. Yeah, so these fractions are a bit strange looking. But what the author of these notes is trying to do, yeah, what the author is trying to do here is just help you conquer your fear of like the worst situation. And this is worse than whatever you'll see in real life. Just double checking that I got these done all correctly. Okay. So anyway, this will be our last question from this particular multi-part question. So yeah, the first thing you could do here is make these all into decimals. You could also make them all into fractions, but because the answer is being asked in decimal form, I wouldn't bother. So I'll just make these all decimals. So that's 2.75. Sorry, a little glitch there on my keyboard. 2.75, 3. Now this is 6 is on forever. You could write that. That means it goes on forever. 3.66666 forever. Or just put 667. It's fine. And then x is to 4.2. So that's 2.75 per 3.667. And then x over 4.2. Cross multiply. I'm just got my calculator there. Thank you, Nicolas. I'll catch up to you. So 15.75. If you divide both sides by that, just double checking. I got something else. Can someone confirm? That's okay. I definitely appreciate it. I actually got 4.30. Oh, you put a plus, I see. Anybody else get 4.30? Now, I didn't put this on my calculator. If you're wondering what did I type? I typed this, by the way. That's what I typed on my calculator. Not that many sixes. So, but generally speaking, I put more than just this accuracy. Yeah, definitely want to include the improper fraction here. I'm not really a fan of kind of taking the shortcut with the decimals, but really, Nicholas, the issue here is that you'll never see these types of proper fractions in a measurement question. So that's why it's a little bit awkward. And plus the question says to round it, so that's why I was like showing it that strategy. If we did go with proper fractions, the strategy, and I'm glad to show it, would be 11 over 4, and then 11 over 3. And correct me if I make a mistake anywhere here. It's been a while, but those look good, I think. 11, 11, 4, 3, 21. I cross multiplied. I did 2.75 times 4.2. Oh, is that not right? No, it's 1155. Yeah, you're right. I think there might be a mistake in the notes then. Well done. I think I made a mistake there on my calculator. Sorry, guys. Did someone confirm that answer? 3.15? Yeah, I think that's good. Back to this question. If you did, what I'm doing here is, this is optional, okay? This is not being asked for. This is extra, just as per a question requested. What I'm doing here is the exact answer. For those that want to see the exact answer, okay? So this is how you would go that way. Notice that we have 4, 3, and 5. I don't want to see fractions, so what I'll do is I'll multiply by the lowest common denominator. What's the lowest common denominator between 4, 3, and 5? Unfortunately, I believe it's 60. So you'd have to multiply them all by 60. That is not fun. So anyway, that would be the unfortunate circumstances. But you could also do other stuff. You could also do other stuff like you could reduce this ratio here to 11 and then make it a 1. Because remember that this ratio here is like the stuff we started with today. You can reduce both sides by dividing by the same number. You could also just take this ratio locally and multiply by 12. You can do all kinds of fun stuff here if you want. I'm just showing you alternatives instead of trying to go for a common denominator. So 3 to 4 is equal to x to 21 over 5. I'm always looking for a way to get the answer in terms of the least amount of mental math. That's what I'm trying to do in this case. Okay, anyway, at this point things are looking better. You could also take this ratio over here, which has the 5 in it, and you can multiply both of these guys by 5 because locally you can play with that ratio the same way. Then you would have here 5x to 21. So this is just an alternative as per a request there. So there you go, okay? But you're starting to see that the numbers are getting really annoying, which is why I would not recommend you do it this way unless you're explicitly asked to do it this way. So 61 divided by 20. I'm sure I probably made a mistake there anyway. 63, that's right. There we go. I just had a feeling I typed something wrong. Okay. So again, my emphasis here, I'll put this in gray. I would not, I'm doing it, but I wouldn't endorse doing it. Okay. You can go back and look at that one. I'll post that on Blackboard, but I want to focus more on the key questions here, numbers 2 and number 6, involving some more blueprints and ratios of masses. This kind of reminds me of the brass question, except that they're giving a ratio instead of percentages. So it says here, if the ratio of two weights is 7 to 3, and the first is 10 pounds, then what is the second weight? So you can write a sentence here. You don't have to write this down, but you could write here, um, 7 is to 3 as 10 pounds is to second weight. This is not grammatically correct. I'm just trying to write down keywords. You see here, 7 is to 3 pounds, 7 is to 3 as 10 pounds is to the second weight. Whoops, that's not what I wanted to do. I wanted to separate it this way. And you can see here the is to is what I was referring to earlier as being the ratio. So trying to deconstruct the words into something a little bit more symbolic, we would have 7 is to 3 as, that's the equal sign, 10 pounds. That's right, Nicholas. The second weight is unknown, and I'll call it X. I like X too. That's exactly what we're doing, because the second weight, we don't know it. We can say here, I'll put the word unknown in there. That'll clarify it better. So the unknown second weight, so that's how you have the X there. Okay, now just for the sake of this explanation, we know that X is going to be in pounds, but you might be like, how do I demonstrate that with on paper with writing? Just leave the pounds there. See, 7 over 3 equals 10 pounds. Just leave the pounds there. Don't touch them. Keep them in there as if they're part of the question, because they are. You'd have 7x equals 30 pounds. You see, you don't have to worry about the unit calculations. You just put them in there. They're along for the ride, okay? 7 pounds over 30 pounds over 7, done. 30 divided by 7 is 4 point something, 4.28, I believe. 4.28, 4.29, yeah, you gotta round up. Okay, so, whoops. There you go, 4.29 pounds. Look for this type of stuff on your test. You'll probably get at least 2 ratio questions. And I promise you, they're not going to be like hard questions. They're just standard ratio questions. I'm really trying to keep this part of the content simpler. Anyway, we have time if you don't mind. We're going to do one more question before we take our break. Our break's going to be a little bit later than usual. But anyway, that's fine. I went slower and I did a couple extra things. Because, like I said, some of you may have not seen this for a long time. So, you know, some of you were like, oh, this is so quick. But keep in mind, some people may not have been in school for a while, so that's why. Anyway, hopefully you've had time to jot that down. I'm going to move on to this last one here involving another ratio in a blueprint. So we have here a line on a blueprint is 14 3/4 inches long. The scale of the blueprint is 1 to 40. Then how long is this wall in reality? So we're looking for the actual size. So I'll just say that here. We say here 14. It's all good, Nicholas. 14 3/4 inches is to actual size. I'll put let the spaces as 1 is to 40. So there's the keywords. So the in there is inches. Maybe I should just write inches. Yeah, that's better. That was confusing me for a second. I was trying to read the word in as in instead of inches. And then here we have that. And I'll put the word unknown here because that helped. We're trying to solve for that. So we have here 14.75 inches. Right away, make it a decimal. Don't bother with the fraction. To x equals 1 to 40. Now, there's many people in this audience that are going to be like, John, all you got to do is multiply by 40. I know there's 13 students here right now. I know that many of you are saying, oh, just multiply by 40. And you're right. You are just going to multiply by 40. But let's go through it systematically so that you can see it with the algebra and with communication on the paper here. So we have that, and then we have 1 over 40. So yes, indeed, you do cross multiply, you get x. Notice that I left the inches in the question, in the actual algebra. And then here you have 14.75 inches by 40. There you go. So we end up with 14.75. Whoops, 14.75. And you get 590. Thank you, Nicolas. I was struggling to type it and to talk. My multitasking skills have diminished. Anyway, perhaps that's an opportunity and an excuse maybe to have a break. We're going to be talking about some examples involving direct proportion, and I'll direct your attention to page 13. Okay, so this first example here involves working with a crew of 10 men, assembling 45 units a day. So how many people are needed if the production is increased to 80 units a day? So this is a very practical question. You know that when you're talking about resources, whether resources is going to be in terms of the effort of employees, or whether it's other things like machines or whatever you have at your disposal to achieve your goal, this type of calculation is very common. So let's take a look and see if we can set up some type of an equation in terms of solving this question. So I find that the way to do these types of questions is to set up a fraction. In other words, on the one side we have 12 men, and well, that's a different E there, and then 45 units. And then here we'll have unknown. We don't know how many people are going to do that. And then we have here 80. Oops. So there's the question. So we just set up a ratio that we can make a quick comparison between the two. But by ratio, I mean just write down a fraction. So in this case, the units are consistent. In other words, here we have units below, literally units of whatever they're assembling. And on the top, we would have men. So that's right. Oh, I like that, Oakley. That's very nice. So what Oakley's done there is figured out how many units per person, or how many persons per unit, but also 21.3 is numerically a good answer. But we need to decide how to round that. So what you've done is excellent there. I'm going to do something here in terms of solving this equation, not because you need to do this for your approach. Your approach is very good. But in situations where the context is confusing, you can fall back on this if you need to. Just momentarily though, I'm not gonna write down the units in the next line. So you can if you want to, but I'm just gonna write this as follows. Cross multiply, and we get 45x equals 12 times 80. After a couple of lines of writing, I will have the same answer as Oakley, which was 21.3 approximately. So 12 times 80 is 960. And then you can divide by 45. If we divide by 45, we indeed get 21.3. Now the issue here is that you can't have 21.3 men, so you have to round it. So what do you round it to? Is it 21 or 22? What do you think? Would 21 achieve the goal? I don't think 21 would. You need to round up to 22. When it comes to resources, you got to round up. So yeah, we need 22 men are needed for this project, for this assembly, okay? for the, let's write it down nicely, the 80 unit assembly. Actually, when you're writing down numbers, whenever you're at a sentence, and the first item in the sentence here is a number, you should write it as in words. Just saying that there. I'm not trying to be going full out technical writing with you. Believe me, guys, I read a lot of papers and a lot of articles and things like that, and all day as a technical writer, when I'm doing that, it gets really, really, it's very important, but also it becomes a little bit more like distracting in terms of trying to explain to you what I want to solve. So that's why the grammar is not always there. But anyway, that's how you should write the sentence. Okay, let's do the next question here. A motor-driven pump discharges that many gallons of water in 2.5 minutes. How long to discharge that many gallons? So you could approach the question the way that Oakley has done, or other classmates of yours, by computing a rate. So in other words, so many gallons per minute. You could also do it using the fractions. Now, I'm going to do it using the fraction because this is the strategy that the author uses as well. So if you're looking at additional exercises earlier, like the examples, you can fall back on the author's explanations as well. So we'll say here we have, it doesn't matter if you write gallons on top or on the bottom. I'll just put gallons on the top because you're comfortable with having time on the denominator when involving rates. So 560 gallons for 2.5 minutes would be the same as 10,900 gallons for an unknown amount of minutes, which we'll call X. So this question, we can avoid the units as long as you can appreciate that they are there and that it's understood that X is in minutes. In the past questions, I put the units everywhere, but now I'm just going to avoid that so that it's less distracting when I write down the algebra. We'll have here by cross multiplication, 560x is 2.5 times 10,900. So 10,900 times 2.5 is a pretty big number. It's 27,250. So then X would equal 27,250 over 560. And hopefully that gives us something meaningful. Can someone confirm 48.7? Anybody else have that? Can someone confirm 48.7 minutes? Thank you, Nicolos. Thank you. Okay, so there you go. That was just the kind of standard question that you'll see for the rest of this section. Again, take a step back and ask yourself, do you think that you'd be comfortable doing these questions on the test? Let me ask you that. Tell me in the chat. How do you feel if question 3 was on your test? Would that scare you? Would you like that? Who would like to see a question like 3 on the test? Who likes this kind of question? Who would look forward to a question like this? Anybody else? Thank you, Nicholas. Thank you, Nicolos. Just 2 people? So everybody else doesn't want to see this on a test? Thank you, Oakley. I need some support here. I thought that this question you would love to have on the test. It's not that bad. It's just fractions, proportions. Yeah. Anyway, thank you, Norris. I hope that the people that didn't respond would feel happy about seeing this question on a test. because it's this ratio proportion stuff is meant to be hopefully easier. So anyway, let's go on and try another question before I embarrass myself a little bit by assuming too much. Anyway, a casting with a volume of that many cubic inches weighs that many pounds. What would the weight of the casting made out of the same metal be if it occupied a volume of 158 cubic inches? So the first thing you want to make sure is that you have a general sense about the final answer. The new volume is greater than the old volume. So that means that we would expect the final answer here to be greater than 19.4 pounds. And that's generally speaking the idea here. When you write down these comparisons, especially with direct proportion, you have a very quick opportunity to identify what the answer will be. Like I know the answer is greater than 19. I don't do multiple choice tests, but if it was multiple choice, immediately you would scratch out all the answers that are less than or equal to 19.4. And you might be wondering, well, anyway, some of you might do something in the future involving multiple choice tests. Maybe a professional exam of some sort. Who knows, right? So I'm just saying, like, it's nice to be able to eliminate answers that are extraneous or not possible. I'm going to put the pounds on top. It doesn't matter which one goes on top, but the reason I'm putting the pounds on top is because I believe that most of you would put it as well because it reminds you of density. I mentioned just as I was introducing the section here that this type of question is related to density because on the numerator we have a mass or a weight if you want, and on the denominator we have a volume. And I know that density is mass per volume or mass per unit volume. So this question, if you're familiar with the density formula, you could calculate the density of the object, of the material, sorry, and then you could use the density to determine the mass of the final volume. Anyway, we're not going to do that here. We're just going to go with direct proportion. More mass, more volume, or more volume, more mass, same thing. So there you go. Let's cross multiply that, and also we'll just set aside the units because they are consistent now. We'll have your 19.5 by 158. And I'm just doing these on my calculator with you. So hopefully you can double check these with me if I am consistent with you there. 3081. I'm just going to go right for the answer this time. So 3081 divided by 120. We should have an answer around 25.7. That seems okay. Can someone confirm that they got 25.7? Awesome. Awesome, awesome. So anyway, that's another one of those types of questions. I mean, hopefully you're seeing that the pattern is the same thing over and over again. Write down a fraction, write down another fraction. That should be an equal sign. Sorry. Did I put a colon earlier? Just a second. No, it's good. I just typed that. I typed a colon here by accident. Sorry about that. There's nothing wrong with that. It's just I wanted to write it as an equation involving fractions. So anyway, these questions really can be done in a couple of steps. So you might be wondering how much do you need to write on the test. So let's say that your test, you got a question like this. What do I need to write? What do I want to see? I want to see the first line. I want to see that you write this down correctly. And then I want to see this. The answer is fine. In terms of intermediate steps in algebra, it doesn't concern me too much. The only thing I don't want to see from people and people that have written tests. Oh shoot, that's a typo. No, you're right, Oakley. That's a typo. I read that as a 4, as a 5. My apologies, guys. That's a 4. Yeah, something was off because I actually did this one earlier. I was just before I stepped into the class today, I was trying to do this one earlier actually, quickly. My apologies there. That's a typo on my part, everybody. That should be a 5, I think, or 4. Let's see if it's a 4. It's a 5, yeah. Oakley, thank you for that. Nicely done. Don't worry, all your test questions will be typed, and you won't have the same issue that I had where I read a number wrong as it's handwritten there. So yeah, that's about it. That's about it for that question. So the red stuff is what I want to see. I was saying that in the past on tests, some students would just write the answer. And often it would be the right answer, but they had no method. And I'd say to them in the chat, in their feedback, I go, I'm going to give you, for the easier questions, I'd give them full marks. But if it's a long question and you just put an answer, I can't give you full marks because you haven't demonstrated to me the method, and the method is just as important as the answer. But anyway, those students that did that corrected their ways. I'm not saying specifically from this section. I'm saying from the roughly 180 students that, or 170 students that I have this semester, or something like that. Anyway, let's move on to one more question. This one involves a grade or slope of a road. So it says here that it is, Nicholas. That's why it's so much nicer when the class sizes are the way they are now. We have our group here. It's supposed to be 40 people or 35 people, but yeah, imagine having 150 people in one class. Imagine having a lecture, a math lecture with like 150 people in it. Can you imagine the chat? The chat would be absolutely horrendous. This is nice, you get total spam. This is nice. You get a nice group of students. They're asking questions. Uh, it's all there's all these formulas for that stuff, Nicholas. It ends up being, it's like one way or the other. There's always a good and a bad to it, I guess. But yeah. So this one's interesting. This one's very practical too. We have a road that rises. Totally. There's a road that rises 2.70 feet in 200 linear feet. So in other words, as you drive along the road, let's drive along the road. Here we go. As you go along the road for 200 feet, you can draw a triangle here if you want. The road will rise, and this is not the scale. The road will rise, that's hard to say, 2.70 feet. You don't need to draw the triangle. I'm just trying to show you that you could use similar triangles here if you like. It says here, how high will the road rise at that slope in 1 mile? So a mile, as we know from way back in the semester, is 5280 feet. So we can answer the question quite quickly. So let's do that. Let's set it up. But for those of you that remember slope, you could use rise over run. So how I did the previous question, some of you could have used density. Here you could use rise over run. Or you could just stick to what I was doing with direct proportion. So we'll say here that 2.70 feet of rise for every 200 feet of roadway is the same as how much of a rise for 50 to 80 feet of roadway. So many of you can solve this question in terms of just getting that as a ratio or a number and saying, well, look, it's roughly whatever, I don't know, like 9 times, or sorry, 9, yeah, something like that. Anyway, and then you could be like, okay, that times 5280. But I'd rather not just do a magnification. I'm gonna just do cross multiplication here. So we'll have here 200x is equal to 2.70 by 5280. And then from that point on, I think things are pretty smooth. 2.7 times a mile is a lot. 14,256. And then divide by 200. That one actually is going to be a pretty easy division. So I got 71 and something. Anybody else get 71.3, I think? Awesome. Thank you, Nicholas. Thank you. Awesome. Thanks, Oakley. Oakley's been clutch for us today. You caught me on my errors, the errors of my ways. Anyway, that's enough in terms of the new material, guys. The rest of today's class is open to your questions and comments. I'll just stop the recording here though, because this is really the end of the lesson part, the actual new material. And really want to thank you for a wonderful semester. You were awesome, awesome, awesome group of students, and you made this situation being online very memorable in a good way.